Hello everyone. Today we're going to be talking about compound inequalities. So first, for a definition, a compound inequality is an inequality that includes more than one inequality. And so there are two different types of compound inequalities that we'll see. The first one are and statements, and those are graphs that go into each other. So for example, I have 4 is less than y, which is less than or equal to 8. And I see that this graph ends up having a line segment here because it's connecting the 4 and the 8. And again, notice that the 4 is an open circle because it's not included, while the 8 is a closed circle because it is included. And basically, this is the same thing as if we were to go ahead and graph both of these inequalities separately, as that y is greater than 4 and y is less than or equal to 8. If I were to graph those, y is greater than 4 and y is less than or equal to 8. And so instead of graphing two different inequalities, we go ahead and just make them into the one line here. And then we also have or statements. And those are graphs that go away from each other. So for example, a is less than -2 or a is greater than 8. I see the graph here, I have those 2 points and the lines are going away from each other. And so this is review. We kind of did this in an earlier lesson as well, but I'm going to write the compound inequality that is given in this graph. So I see for this first one, I have an and compound inequality because I notice that this graph goes into each other. And I see that my endpoints are 0 and 7, so I have 0, x, and 7. And then I have to figure out the inequalities. Well, I see both of these are open circles, so that means that we'll have less than. And notice they are both pointing the same direction. It's always going to be this pointing in this direction. And that's because this is the same thing as saying x is greater than 0 and x is less than 7. But instead of writing it out like that, we have it all in one compound inequality. Okay, and then looking at number 2, I see I have graphs that are pointing away from each other, so I know this is going to be an or statement. And so when writing an or statement from a graph, we're really just writing two different inequalities. So I see for this first one, I have my endpoint at 0, and I'm pointing to everything less than it. So this is going to be x is less than or equal to 0. And I put the less than or equal to because it's a closed circle. And then here I see this is at 9, is pointing to everything bigger than 9, so it's going to be x is greater than or equal to 9. And then we'll look at graphing compound inequalities. So here we're actually just going to go ahead and graph it. So this first one I have y is less than 2 or y is greater than 7. So y is less than 2, so I'm going to put an open circle at 2 because I have a strictly less than. And then I want to draw my graph everything less than 2. Y is greater than 7. Greater than is strictly greater than, so it's an open circle. And I want to draw everything greater. Now for this last one, I have -4 is less than g is less than or equal to -3. Or +3, sorry. And so here I have that and compound inequality. And we learned that these always go into each other. So instead of drawing the 2 like I did in this example here, I'm just going to draw my endpoints and then I'm going to connect them with a line. So at -4, I have a strictly less than, so that means it's going to be an open circle. At 3, I have a less than or equal to, so that means that's going to be a closed circle. And then I'm going to draw a line between.